Hi students, welcome. In this video we finally get to do some math. This is really the first video of the semester where we work with numbers, qualitative data, and what we're going to be making is called a frequency table. Okay, so chapter 2 is all about exploring data with tables and graphs, and this video is actually about section 2.1, which is frequency distributions for organizing and summarizing data. Okay, now frequency distributions are also called frequency tables, and we'll be doing the math necessary to make a frequency table. And it's exactly that, it's a table. But the reason these tables are useful is they allow us to organize and see what's going on with our data. And then also later on, in section 2.2, we'll be learning how to make histograms, which are a special type of bar graph. It's a bar graph that's constructed using a frequency distribution or a frequency table. Okay, but for now, 2.1 is just tables. Frequency tables. So a frequency distribution or frequency table is often helpful in organizing and summarizing data. A frequency distribution helps us to understand the nature of the distribution of a data set. So distribution means how is the data spread out, or is it all close together, that kind of thing. So our goal in these slides is just to get a basic idea about what a frequency table is. So ultimately, a frequency table is going to look like this, and we're going to learn the steps necessary to construct a frequency table. As you can see here, this organizes the data in a very easy to read fashion. Okay, and then after we get done with the slides, I'm going to do a second part of this video where I show you some additional equations that you'll need to do your homework and quizzes, and also to do well on the exam. Because there's some things that are not in our slides from our book, but those are equations that I can give you that will help you with your homework. So we'll see that after these. Okay, so let's go through this. Okay, so going back, we already talked about this, but here's another slide kind of summarizing it. Frequency distribution or frequency table shows how data are partitioned among several categories or classes by listing the categories along with the number, frequency of data values in each of them. Okay, so if we look at this frequency table that we're going to be constructing today, you'll notice that the numbers on the left here are supposed to represent a range of possible daily commute times in Los Angeles. So the way you read this is the first class, that's the second class, that's the third class, fourth class, fifth class, sixth class, and seventh class. So each row in this table is called a class. Okay, so how you read this is from 0 to 14 for daily commute times. Well, all the daily commute times that were between these two numbers, there were a total of 6 of them. So the frequency is 6. Okay. And then between 15 and 29, there were a total of 18 data values that were between those two numbers, and so forth. And the nice thing is you can just look at the frequency over here. So when you look at the frequency, you can kind of see the general distribution or shape of the data. So here it starts low at 6, then it jumps up to 18, then it starts to gradually decrease to 14, and then it has a large jump down to 5, and then 5 again, and then 1 and 1. So it's nice because it's organized and everything's in order, So we can sort of imagine the shape, even though we don't have a graph, at least it's organized. Okay, so that is our goal, to construct this table. So let's learn how to do that. Okay, so in order to construct the table, we're going to have to learn some definitions. Generally, what people start with are the lower class limits. Okay, so the lower class limits are the smallest numbers that can belong to each of the different classes. Okay, so like the lower class limits that we would have in our table that we're trying to construct are each of these numbers on the left. So here the lower class limits are going to be 0, 15, 30, 45, 60, 75, and 90. So all these numbers on the left are the lower class limits. And we'll talk about how to find those, but it's good to know that. And then the numbers on the right over here, so 14, 29, 44, 59, 74, 89, and 104, these are called the upper class limits. Obviously because they represent the upper range of the values that we're including here. So lower class limits are the numbers on the left, upper class limits are the numbers on the right. Okay. Or in the book they say upper class limits are the largest numbers that can belong to each of the different classes. Okay? And then next thing is class boundaries. Now they don't give us a formula for class boundaries in the book, but when I make part 2 of this video, I will show you how to do your homework, and in that one I will give you a formula for the class boundaries. But for now, just know that the class boundaries are the numbers used to separate the classes, but without the gaps created by class limits. Okay? And the basic idea with the class boundaries is they'll be halfway between an upper class limit and the lower class limit of the next class. Okay, so like the class boundary between 14 and 15 would be 14.5. Okay. But again, we'll see that more when we're actually doing an example. But essentially, to get the class boundaries, what you can do is you can take all the lower class limits and you can just subtract 0.5 from each of them. Okay. But again, we'll do more of that later. All right, some other definitions here. Class midpoints. This is something that we'll also be calculating when we're doing our homework. In the book, they say that the class midpoints are the values in the middle of the classes. So they're halfway between the lower class limit and the upper class limit. So the way you calculate the class midpoints is each class midpoint can be found by adding the lower class limit to the upper class limit and dividing the sum by 2. Okay, so it's the average of the lower class limit and the upper class limit. Okay, and then the last definition that we're going to learn is the class width. So the class width is the same as the difference between 2 consecutive lower class limits. But it's not just that. It's also the difference between 2 consecutive upper class limits. It's also the difference between 2 consecutive lower class boundaries. And it's also the difference between 2 consecutive class midpoints. So the class width is very useful. Once you have it, you can actually, once you have your first lower class limit, you can just repeatedly add the class width to get all the other lower class limits. All right, so we'll see that when we're doing an actual example. All right. So now, I kept these slides here for procedure for constructing a frequency distribution. You may find that these slides are not as helpful on your homework as you would hope, but we're still learning about them just to understand a frequency distribution, aka a frequency table. So this is what you would do if you had a bunch of data values and you wanted to construct a frequency table from scratch. Fortunately, on your homework, we're not going to be constructing frequency tables from scratch. They will give you part of a frequency table and then they will ask you to finish it on your homework. And it'll be something like that also on the quiz and the exam. So it won't actually be as long as the example we're doing in the slides. But it's still good to see this to learn. Okay, so step one for constructing a frequency table is you select the number of classes. And they say here in the book, it's usually between 5 and 20 classes. So remember that classes are the same as rows in our table. So if we look at our table, our frequency table, the number of rows represent the number of classes. So like I said towards the beginning of the video, first class, second class, third class, fourth class, fifth class, sixth class, and seventh class. Those are names for each of these rows. Okay? So after you select the number of classes, then you calculate the class width. Keep in mind, in your homework, you're very likely not going to have to use this formula because on almost all of your homework problems, maybe even all of them, they just tell you what the class width is, which is nice. But this is the formula you would use to construct a frequency table from scratch. So the formula is class width is approximately equal to the maximum data value, so the largest data value, minus the minimum data value, which is the smallest data value, and then you divide by the number of classes. And then after you get this, you're very likely going to have a decimal for the class width, but the class width actually has to be a whole number, which means it can't be a decimal. So if you do get a decimal, they say round this result to get a convenient number. And usually you just want to round up. So for example, if you had a class width, you use this formula and you got a class width of 11.2. You got a class width of 11.2. After you use this formula, then what most people would do would be they would round up. So I know when they say round, you would think that you would round this normally. But you actually round up to the next whole number. So 11.2, if your class width were 11.2, you would round up to 12. Okay, but again, you probably aren't going to actually need to use this formula a whole lot in your homework. We're just learning about it so that we can learn where everything came from. But like I said, in your homework, they generally tell you the class width. Yeah, that is the class width. So that would be the second step in constructing a frequency distribution. Okay, and then on our next slide, we have the last three steps to constructing a frequency distribution. Okay, so the third step is choose the value for the first lower class limit by using either the minimum value or a convenient value below the minimum. So remember that the minimum is the smallest data value that you have. And that's generally the first lower class limit. Okay, sorry, I said the last three steps. There's actually 4 steps here. Okay, so next step, step number 4, using the first lower class limit, repeatedly add the class width to obtain all other lower class limits. We'll come back to these. I know this is a lot of stuff to read. We'll come back to these when we're actually doing an example. But when you have the class width and you have your first lower class limit, you can just keep adding it to get all the other lower class limits. All right, step 5 is list the lower class limits in a vertical column and then determine and enter the upper class limits. So the way you get the upper class limits is you just take each lower class limit and you subtract 1 from it. So it's always 1 less than the next lower class limit. So for example, if we look at the table that we're going to be constructing today in this video, we'll notice that this first upper class limit of 14 is the same as the second lower class limit of 15, but they subtracted 1. So 15 minus 1 is 14, and you'll notice that it holds this pattern all the way through the frequency table. So for example, here, 30 minus 1 is 29, 45 minus 1 is 44, 60 minus 1 is 59, and so forth. And something else that's important to notice is you don't have to just keep subtracting 1 from each lower class limit to get the upper class limits. Another way of doing it is to, once you have the first upper class limit, you can once again just repeatedly add the class width to get all of the other upper class limits. So like here, 14 plus 15, which is going to be our class width, gives us 29, plus 15 is 44, plus 15 is 59, and so forth. Okay. All right. Okay. And then the very last step that we're going to take is once we've constructed the lower and upper class limits in our frequency table, then we are going to take each individual data value and put a tally mark in the appropriate class. When you add up the tally marks, that will give you the frequency for each class. Okay, so let's go through all this and see how to construct that frequency table that they have later in the slides. Okay, so example, commute time in Los Angeles. Using the daily commute times in Los Angeles, in table 2.1 from the chapter problem, this is straight out of our book. Follow the above procedure to construct a frequency distribution shown in table 2.2. And here they're nice, they tell us how many classes to use. They say use 7 classes. So what we're going to be constructing is this table right here. This is our goal. All right, but the actual data values are listed in here. So these are all of our data values. So each one of these data values represents a daily commute time of a person driving a car in Los Angeles. And as you can see, we have 1, 2, 3 rows in this table. And then for columns, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that means there are 3 times 17, and then either on a calculator or just writing it out, what is 17 times 3? Well, it doesn't show up in your times tables, but it should be pretty easy to calculate. So 17 times 3, 3 times 7 is 21, carry the 2. 3 times 1 is 3, plus 2 is 5, so that's 51. So that means there are a total of 51 data values here. All right, these are all the data values in this table right here. All right, so how do we construct this table? Well, we're just going to go ahead and follow the steps and construct this entire table from scratch. Okay, so step 1, they've already told us to use 7 classes, so that's already done. They told us to select 7 as the number of desired classes. Okay, step 2, calculate the class width as shown. Okay, so here we want to round up. And when they were doing this problem, they actually rounded up 12.1 to 15, which is a little confusing because normally people would round up to the next whole number, but here they're actually rounding up by almost 3 whole numbers. but like they said, it's for a convenient number. And when you're doing your homework, your quiz, and your exam, you're probably not going to actually have to use this formula. All right, but the way they use the formula is they did the maximum data value minus the minimum data value. So the maximum is going to be the largest number of all these numbers in our data values here. So looking at these, in the first row, the largest data value I see is 75. And then in the second row and the third row, I see 90, which is larger. Okay, so it looks like the largest data value is 90. Okay, so this one right here. So the largest data value is the same as the maximum. Okay, and then the minimum is the smallest data value. So looking through this table, in the first row, the smallest data value is 8. In the second row, the smallest data value is 5, and 5 is smaller. So far, 5 is the smallest data value. In the third row, the smallest data value is 5. Oh, by the way, I said there were 51 data values, but I neglected to notice that this very last box on the bottom right is blank, which means there were only 50 data values. So I did the number of rows times the number of columns, and I said there were 51 data values, but we're actually one less because this last box is empty. So we have a total of 50 data values. 50 data values. Okay. Anyway, the maximum was 90, and then the minimum, which is the smallest number we could find, was actually 5. Okay, so here, the minimum actually just happens to be right next to the maximum. So here our minimum is 5. Okay, and then, so what they did to calculate the class width is they did 90, which was the maximum, minus the minimum, which was 5, and then they divided by the number of classes, which is 7. So 90 minus 5 is 85. Okay, and then 85 divided by 7, if you do that on a calculator, is usually the quickest way. That will give you 12.1. But even after all that work, they're just rounding it up to a more convenient number of 15. So there's not really any way that's set in stone that you have to calculate the class width, which is probably why on your homework you're never really going to have to use this formula. But if you were doing a statistical study in the real world, you would have to do this process here. And then for the class width, like I said, just choose a convenient number if you're doing this in the real world. Okay, let's go to step 3. So step 3, here they say, let's select 0 as the first lower class limit because it is below the value 5 and is a very convenient starting point for the commute time. So on most problems, they would choose the minimum data value as a starting point, but here in this example from the book, they decided to choose 0 as the first lower class limit. Okay? All right, now in step 4, we're going to be needing to add the class width, which we said was 15, to the starting value of 0 to get all the lower class limits. We're just going to keep repeatedly adding 15 over and over again. So class width of 15, we add it. So we start at 0 and we do 0 plus 15 is 15, plus 15 is 30, plus 15 is 45, and so forth. So this is going to give us all of the lower class limits. Okay? So actually, let me switch to just the camera here. So So we've got the table that they're constructing. They decided to start at 0. So that's going to be our first lower class limit. And then we said that the class width is 15. Class width was 15. Okay. So 15 equals the class width. So then once you start with your first lower class limit, to get all the other lower class limits, we're going to just keep adding the class width. So 0 plus 15 is 15. 15 plus 15 is 30. 30 plus 15 is 45. And we're just going to keep doing this process until we have a total of 7 classes, because they told us we needed to have 7 classes. Remember that the number of classes is the same as the number of rows in our frequency table. So 1, 2, 3, 4, 5, 6, 7. So now I have a total of 7 rows in my table. And those are supposed to look lined up vertically, but it's kind of difficult for me to write on this board. I'm still getting used to it. Anyway, all these numbers on the left are called the lower class limits. And then how do we calculate the numbers on the right? How do we calculate the upper class limits? Well, going back to our notes, we're going to be looking at step 5. Okay, so step 5 was, we kind of already started on step 5. We listed the lower class limits vertically. And then from this, we identify the corresponding upper class limits as 14, 29, 44, 59, and so forth. So like I was saying earlier, the way you get these is, to get the first one, you just take the second lower class limit and you subtract 1. And that will give you the first upper class limit. Okay, so I'm going to start using my own notation here. So upper class limit 1, UCL 1, that means upper class limit number 1, is going to be lower class limit number 2 minus 1. So that's just a formula, really, for calculating the first upper class limit. So all you do is you take 15 and you subtract 1 to get the first upper class limit. So 15 minus 1 is 14. And then to get all of the other upper class limits, you just repeatedly add the class width over and over again. So we said the class width was 15. So then to get this upper class limit in the second class, we do 14 plus 15, and 14 plus 15 is 29. And then we just keep adding 15 each time. But adding 15 is harder than just looking at these numbers here and subtracting 1. So I personally would recommend that you take the, it's up to you how you want to do it, but it's usually faster to just take the lower class limit of the next class and subtract 1, because it's a lot easier to do than adding 15 to each upper class limit. Okay, so the next one is going to be 45 minus 1, which is 44. And then after that, we have 60 minus 1, which is 59. 75 minus 1, which is 74. And then 90 minus 1, which is 89. And then we do have to do the very last upper class limit by adding the class width. Okay, so what is 89 plus 15? So, well, 90 plus 15 would be 105. So 89 plus 15 is going to be 104. So again, the way I got that last one was I just did 89 plus a class width of 15, which should give you 104. And all these numbers here represent the lower class limit and the upper class limit for each class. And remember, because our data values in this problem that we're doing, we're representing commute times, that means these numbers here represent a range of commute times in minutes. Let me write that down. So, commute times and remember that these were in minutes. Okay? So that right there, what we've constructed so far is all of the lower class limits and the upper class limits. Okay, and then how do we finish our frequency table? How do we finish this? Well, what we do is actually kind of a pretty easy process. The rest of this problem is pretty easy. So what we're going to do is, let me go back to the slides while I erase this. So what we are on is step 6, this one right here. So for step 6, we want to enter a tally mark for each data value in the appropriate class. Okay? And then we add the tally marks to find the frequencies shown in the table. Okay, so this is actually a pretty mindless process for most people. So as long as you don't get too bored and mess up, this is pretty straightforward. So let's figure out how they got these frequencies. We'll actually go ahead and go through the whole problem up here on the slides. Okay, so I'm going to have to jump back and forth between the slides and this screen. I'm going to go ahead and overlay them for now. So what we need right here is this frequency table, not the frequency table, but the actual data values. So looking at these data values, actually let me try something here, make this more readable. Okay, that helps. That helps a little bit. So these are our data values here. And then what we do in our table is we go ahead and do a tally. Okay, so we do a tally for each class, which just means one by one, we cross out each data value and put a tally in the appropriate class. So let's look at the first data value is right here. So the first data value is 18. So what I do is I cross out 18, which is the first data value, and then I put a tally in the correct class. So as you can see, 18 is between 15 and 29. So that means we put a tally in the second class. Okay, and then we just continue this process. So it's a little bit tedious. So what we do next is 25, cross that out. 25 is also in the second class, so I put a tally there. And then we just continue. So next one is 45. Let's see, what class is 45 in? That's going to be this class down here. 45 to 59. Next one is 75. Okay, 75 is in this class down here. It's actually the 6th class. Okay, so as you can see, it is a bit of a mindless process, but at the same time, you don't want to completely zone out. You do need to put the tallies in the correct place. Okay, so cross out 60, put a tally there, and so forth. The next one is 40, put a tally here. After that, we've got 25, put a tally right here. Cross out 8, put a tally in the first class. Cross out 50, put a tally between 45 and 59. Cross out 10, well, there's two 10s. So I'm going to put two tallies in the first class. So now we have a total of 3 tallies in the first class. And then once you get more efficient, you might want to do what I like to do, which is I start crossing out multiple numbers in a row. But if that's too complicated, just do them one by one. So like me, what I would do next is I would do 30 and 15. So here's 30, there's 15. So I'm doing 2 at a time to save a little time. 25 and 50. So 25 and 50. 20 and 30. Okay, so 20 and 30. Okay, so 20 and 30. Okay, and if you go through the rest of this, I don't want to take up too much more time on the video, but after you do the rest of these, I'm going to kind of just skip ahead here. After we've done all of these, you're going to find, you're welcome to do them on your own or just watch the video. You're going to find that in the first class here, we happen to have a total of 6 tallies. And remember with tallies, once you get to number 5, you put a slash through the first 4. So we kind of count in 5. So we go 1, 2, 3, 4, and then we put a slash for 5, and then we have a 6. Same thing that I did over here with the second class. Okay, and if we look at the second class, we're going to see that we have a total of 18 tallies. If we go through that whole process that we were doing with the whole table, you're going to find that you have 18 tallies. So it's going to be 5 plus 5 is 10, plus 5 is 15, plus 3 is 18. So if you did it correctly, it'll look like that. Okay, and then next one, you're going to have 14 tallies, then 5, then 5, then 1, then 1. Okay, so 14 tallies. If you tally up all those numbers, you're going to have 14 in the third class. So that's going to be 5 plus 5 is 10, plus 4 is 14. And then we said in the next 2 classes, we had 5, 5, and then 1 and 1. So if you actually tally up all those data values, this is what it would look like if we just continue that whole process. And then the number of tally marks is actually the same as the frequency. Okay, so the number of tally marks is actually the same as the frequency. Okay, so then all you have to do to finish the problem is just count the number of tally marks in each class and write that as a number, and that number represents the frequency of that class. And frequency basically just means, a frequency basically just tells you, well, how many of our data values are in a particular range of numbers. So in this first class, the tally was 6, which means that we can just erase the tallies and write 6. And that's our first frequency. Okay? And then in the second class, we had a total of 18 tallies, which means that the frequency of the second class is 18. Third class, if you go through the whole problem, you get a total of 14 tallies, which means the frequency of the third class is 14, and then so forth. So next one is 5, then 5, then 1, and 1. Okay? And that's the whole thing. And then once you have them written as numbers, then they're no longer called tallies, they're called frequencies. Okay, so those tallies are just, you do the tallies in order to make it easy to count each frequency, But after you're done with the tallies, then you can either erase them like I just did, or you can write it over on the right side. You can write the tallies and then make a new column representing these frequencies. It's up to you. But this right here is the completed frequency table. And this whole process is very long, as you can see. But the good news is on your homework, you're not going to have to do an entire thing by scratch. You're not going to have to make an entire frequency table by scratch. Okay? All right. So let's go back to the slides. There's a little bit more we have to learn about. So we have just constructed the frequency table. What you'll note here is the frequency table that we have on this final slide. So that's how you construct a frequency table from scratch. Long, kind of arduous process, really. All right. Now, for the slides, we need to talk about another topic here called a relative frequency distribution. Okay, so for a relative frequency distribution or percentage frequency distribution, each class frequency is replaced by a relative frequency or a proportion, but usually people write those as a percentage. Okay, so what we've got here is the relative frequency for a class. The relative frequency for a class is the frequency for that class divided by the sum of all frequencies. Okay, so relative frequency for a class is the frequency for that class divided by the sum of all frequencies. Okay, and then the next thing there is actually that I wanted to talk about is if you want to write it as a percentage, you just take the decimal that you get from the relative frequency and you multiply it times 100%. And that gives you the relative frequency as a percentage for that class. So the interesting thing here is that you should note is that even though these formulas look complicated, really the second formula is just the same as the first formula. It's just they multiplied by 100%. So all they're saying in these two formulas is once you do the relative frequency, you get a decimal. And then obviously to convert a decimal to a percentage, you multiply by 100%. And then that's all you have to do. Okay? So let's go ahead and go back to our table here, and let's see if we can calculate the relative frequencies. Now for these, it's recommended that you use a calculator. So I'm going to go ahead and get my calculator out. Okay? So far in our table, we have the lower class limits, the upper class limits, and then we have the frequencies. Okay? Actually, let me make this look a little bit better so we can read it. And then over here on the right, we're going to be doing the relative frequencies. And this is important for your homework. Okay, so relative frequency. Oops, that was a little bit too high. Let me write a little bit lower. Okay, that's about perfect. So relative frequency. The formula for a relative frequency is going to be F, which is your frequency of that class, divided by N, which is the sum of all frequencies. Okay, and then we're also going to be multiplying by 100% if we want to write it as a percentage. So let me erase this. Okay. All right, so relative frequency is the frequency of that class divided by the sum of all frequencies, N. So for the first class, our frequency was 6. So we're going to be doing 6 divided by n, which is the sum of all frequencies. Now n, which is the sum of all frequencies, is also the same as the number of data values. So if you add up all the numbers in this column right here under frequency, that will give you n. And I believe we said n was 50 on this problem. But I'm going to get my calculator real quick just to make sure that it's 50. Okay. So on my calculator, I'm going to, first of all, add up all these frequencies and make sure we have a total of 50 data values. So 6 plus 18 plus 14 plus 5 plus 5 plus 1 plus 1. 50. So that means n is going to be 50 here. So the first relative frequency is going to be the frequency, which is 6, divided by 50. So 50 we got by just adding all these up. And then, of course, 6 divided by 50 is difficult for most people to do in their head. So once again, we want to use a calculator. So we do 6 divided by 50, and that gives us a decimal. So here we've got 0.12. Okay? And then if you want to write that as a percentage, you just multiply it by 100%, which basically just means you move the decimal 2 places to the right, and then you write the percentage symbol. Okay, so it's not too bad. Where's my other marker? Oh, it's hiding from me somewhere. Oh, well, I'll just get a new one. Okay. So anyway, all we have to do here to convert from a decimal, which is our relative frequency, to a percentage, is we multiply by 100%, so that means we move the decimal 2 places to the right. Okay, so 0.12 is the same as 12%. So that's the relative frequency as a percentage. Now, why do we care about relative frequency? Well, percentages can sometimes be more helpful than just frequencies, because then we can see the relative importance of each class. Okay, so let's go through the rest of these relative frequencies real quick. So we're just using this same formula, and we already figured out that n, which is the sum of all frequencies, is 50. Okay, so on all these, we're going to be dividing by 50. So on every single one of these, we're going to be dividing by 50, because the number of data values, which is the sum of all frequencies, is never going to change. And then for the numerator of each of these fractions, we just use the frequencies themselves. So the frequency of the second class is 18. So we're going to have 18 over 50, and then 14 over 50, and so forth. 5 over 50, 5 over 50 again, 1 over 50, and 1 over 50. And as you can see, because there's so many of these, calculator can really make this a lot easier. So we do 18 divided by 50 first. That gives us 0.36. And then if we move the decimal 2 places to the right, that's going to give us a relative frequency percentage of 36%. Okay, and so forth. So 14 divided by 50 on the calculator gives us 0.28. And then moving the decimal 2 places to the right gives us 28%. 5 divided by 50 is actually 0.1. And with this one, how do we move the decimal 2 places to the right when there's only 1 digit there? Well, you still move it 2 places to the right, but then because there's an empty space here, you have to put in a 0. Okay, so we put in a 0 for that empty space. So that's actually going to give us 10%. 10%. Sorry, I wrote a little bit too far over here. Okay, and then of course, because we already did 5/50, we don't have to do it again. So this next one is also going to be 0.1, which is 10%. And then for the last two, we have to do 1/50 on our calculator. So 1 divided by 50 gives us 0.02 as a decimal, 0.02. And then if we move the decimal 2 places to the right, we're going to get 2%, which is actually my favorite type of milk, is 2% milk fat milk. Interesting fact. If this were a class in person, I would ask you what your favorite kind of milk is, but I can't because you're just watching the video. All right, anyway, that is the process that you use when you're calculating the relative frequency. Obviously, you don't have to always write as much as I did there. I just wanted to write it out so everyone understands what's going on. But when you're actually doing it for your homework and quizzes and exams, you can just do the division and then move the decimal over so you don't have to write so much. Okay? Cool. So that pretty much finishes most of the slides. So let's go back to the slides real quick. So we used those two formulas for relative frequency. We used the first formula when we just divided, and then when we move the decimal 2 places to the right, that's the same as multiplying by 100%. Okay? And an interesting thing that they say here on the slides is the sum of the percentages in a relative frequency distribution must be very close to 100%, with a little wiggle room for rounding errors. So I'm just curious if all of our percentages add to 100. They very well may not, but let's take a look at them. Let's just add them up on a calculator and see what they add to. I don't think we rounded anything here. We didn't round anything. So my guess would be that this will actually add to 100%. But if you do end up having to round, that can cause a rounding error. But anyway, let's add these up. So adding up all these numbers, 12 plus 36 plus 28 on our calculator. So 12 plus 36 plus 28 plus 10 plus 10 plus 2 plus 2 equals 100%. So because we didn't round anything, all these percentages do end up adding to 100%. But if we had to round any of these numbers, that could have introduced an error, a rounding error. So you may see that if you do have to round, they won't round correctly so that when you add them all up, they equal 100%. You might get like 103% when you add them all up, or you might get 97% or 96%. But we didn't have that problem because we didn't have to round. Okay, and then here we can see this is a relative frequency table that they have here. Notice this is the exact same thing that we just constructed by hand. 12, 36, 28, 10, 10, 2, 2. But this is called a relative frequency distribution or table because it just lists the relative frequencies. Now the table that I made sort of combines a frequency table, which is these first two columns, with a relative frequency table, which can easily be constructed once you have your frequency table. Then as you can see, you're just doing each frequency divided by the sum of all frequencies. So if you're doing a relative frequency table from scratch, this is how I would recommend doing it. Even though your homework isn't that hard, I just thought I'd show you how to do everything. Okay, so looking at the slides, I just wanted to talk about a little bit more. So I'm going to talk about these slides while I erase my light board here. Okay, so in statistics, We are often interested in determining whether the data have a normal distribution. So when you think of the word normal from the real world, if something is normal, that means it's kind of ordinary, if you will. It's what we kind of expect. Now, the word normal in statistics actually means something more specific, but the reason they're called normal is they're really the most common type of distribution, or at least one of the most common distributions that you see in the real world. Okay? So, the frequencies start low, then increase to one or two high frequencies, and then decrease to a low frequency. That's the definition, the first part of the definition of a normal distribution. So the frequencies have to start low, increase to a maximum, and then decrease down to a low frequency, once again. And then the other requirement here that you're going to see is requirement number 2, which is the distribution is approximately symmetric. So symmetric means the left half of the graph is roughly a mirror image of the right half. And I know we don't have graphs yet, so this is a little bit hard to picture. But it's just saying, if we look on the next slide, this right here is an example of a normal frequency distribution. So the frequencies start low, as they say here, for a normal distribution. So they start at 2, then they increase to 4, to 10, and then 18, which is the maximum. All right, and then they decrease back down. So they go down to 10, then to 4, and then 2. And they decrease to become low again. So even though we don't have a graph, we can still say that this is approximately a normal distribution because the frequency starts at a minimum, rises to a maximum, goes back down close to the minimum or at the minimum. And this is also symmetric. So how do we know it's symmetric? Well, here's the middle at the maximum. We'll notice that this side is roughly the same as this side. Well, and in fact, in this particular distribution, they really are mirror images. So if we look at the left half, we go 18, 10, 4, 2. And then the right half is going to be 18, 10, 4, 2. So later on when we're graphing, later in the course, we're going to see that a normal distribution has what's called a bell shape. So right now that might be a little bit hard to picture, so I'll do a quick sketch. So bell shape looks something like this. But it's supposed to be symmetric. Let me draw it one more time. Okay, so it's supposed to be symmetric. So the left half is supposed to be a mirror image of the right half. So with a normal distribution, when we do graphs, it's going to roughly have this shape. It doesn't have to be perfect. So it starts at a minimum, the graph is going to rise up to the maximum, and then it's going to come back down to a minimum. And then if you look at the middle of the graph, the middle is right at the maximum. And then the left half of the graph and the right half of the graph are roughly mirror images of one another. So if you look at the left half, it's roughly a mirror image of this right half. So that makes it normal. So we're going to be seeing this normal distribution all through the course, but for your homework, quizzes, and exams from this section, we don't unfortunately get to see the picture yet, so we just need to look at the numbers and try to make sure that the frequencies start low, increase to a maximum, and then decrease to be low again. Okay? Cool. So that is the end of these slides. Now this is just going to be part 1 of our video from this section. So now I'm going to record a part 2 to this video where I kind of give people a tutorial and some helpful formulas for their homework. And I'm thinking I will split them up into 2 videos since they're pretty long. Okay, so this is the end of part 1 of section 2.1. Thank you for watching.